Hello, I welcome you all to this another interesting screencast, and the problem reads replace the loading by an equivalent force and couple moment at point A and at point B. Both these problems are coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Right, so we have been asked to replace the loading by an equivalent resultant force and couple moment at A, the first case, and then at B in the second case. So we have, let's call this point here C. So from A to C, we have this trapezoid or distributed load, which we can uh, um, write into regular shapes. So write it into rectangular and triangular. And then from C to B, we have a rectangular distributed force. So let's partition this trapezoid into two so that it's easier to work with. So we have one, let's say this one that we've just partitioned, the one in red is our rectangular, and the one in blue is our triangular. Great. So let's start with the one in red. So we are going to have, let's say, an equivalent force, the one in red like so, and the one in blue, let's say we'll have it somewhere there like so. All right. Great. Let me just reduce this a little bit. All right. And then we are going to have their location like so. These are their location from A to C along the longitudinal length, which we will need to map on the Y, on the vertical Y and the horizontal X. When we begin to take, in fact, we don't even need to map, right? Because these forces are already perpendicular to this particular member or to the lever arm, so moments will be just taken the way they are. For at A, when we are taking moment about point A, but when we are taking moments about point B, we need some components. Not some. We do need some components. Great. Right, so let's write these particular forces. So this one, the rectangular one, is the area under the load diagram. So this is a 50. This is a 50 by the length 6, which is equal to 300. And then this one is area under the load diagram, which is half times 6. Okay, let me start with the intensity. Half times the intensity, which is 100 minus 50, right? Because we are looking at this. You see this? This is 100 minus 50. Okay, is that fine? Yes. And then times the length, which is 6. So this gives us which is 100 by 50 is 50. 50 by 6 is 300 by half is 150. Is that so? Yes. So 0.5 by 50 by 6 is 150. Great. Then let's find out these particular distances. This one here, it is half the length. So this is 1/2 times 6, which is going to be equal to 3. So this is 3. And then this one here, it is 1/3, 1/3 of 6, which is going to be equal to 2. So this is 2. So we have a 3, we have a 2, therefore the one in between is going to be what? 1, because the overall length is 6. So this is 1. Great. So like we said, we are going to need to map these distances here. Let me just, especially when we begin to take moments about point B. So let me do it in advance. I'll need this. So we'll need this distance here. I'll need this distance here. So this distance here, I'll need this distance here and this distance here. Okay, I'll need these two distances. Alright, I'll need these distances here. We already know the slope here. The slope is 60, and we also need this particular distance here for this force. Let me use a slim one. This one here also need this distance. Let me use another color, maybe a blue. Alright, so let's say this distance here, so we need this distance here. This one here like this, and I also need this distance here like this. Okay, great. So we need those distances there. Let me get this. Alright, great. So let's add some information. This one here, it is because this also is the same. This is 60. This is 60 here. This is 60. So this one here is going to be equal to, the length is 1 plus 3. Okay, so 1 plus 3, 1 plus 3, which is a 4. So it becomes, this one becomes a 4 sine 60. This one becomes, is a 3 sine 60. Okay, all right, let me just write it in blue. This is a 4 sine 60. Okay, and I take it closer, this one, and we say this one is a 3 sine 60. Okay, and then this one, it is a 4 cos 60. This one, it is a 3 cos 60. Alright, I think we have all the information that we need. So with all this information, we just need to also add one piece of information here, which is the equivalent for this distributed on top here. Okay, and this one is also going to just be equal to 50. The area under the load diagram, 50 times 4, which is just equal to 200. And these dimensions are as follows. Just half the length. All right, there we go. Great. So we have this one is as half of 4. Half of 4 is equal to 2. Okay. So this is also equal to 2. Great. So let's start the work now. We want to find moments about point A. Replace the loading about point A, the equivalent force, and the couple moment at point A, and we replace the loading also by an equivalent force and couple moment at point B. So let's start with point A. Okay, so let's call this as case 1, which is 4-152. Great. Alright, so we start with the summation of forces. So we say summation of forces. Mind you, we're going to have components here which I didn't indicate. We'll have some components here. It's a little bit clustered, so I'll just indicate the angles. We're going to have components here. This is one. Let me put one somewhere there. Okay. So we are going to have this angle here and this angle here. These angles here. We know that this particular angle is 60. This is 60, which is this one here. Therefore, these angles here, they are also going to be equal to 60. These ones, this is 60, and this is also 60 degrees. All right. So there are going to be components also there, okay, which I have not indicated because of space. So say summation of forces in the y going up in our reference, this is going to be equal to our resultant force in the y equal to minus 200, and then 150 will have a component which will be minus 150 cos 60, and then 300 will also have a component which will be 300 cos 60. Okay, great. Then FRR, this is therefore going to be equal to that's minus 200 minus 150 cos 60 minus 300 cos 60. So this gives us a minus 425. Okay, and then we'll have summation of forces in the x going in this direction as our reference. We'll call it as FRX, and this is going to be equal to, we'll have a component which is positive 150 sine 60 plus 300 sine 60. Okay, so we have these components here. We have one component, let me draw them. We have one component here. Let me draw using the colors. We have this component here, then we have another component in this direction like this, and then for red you will have one component here, and then we'll have another component like so. Okay, so those are the components. Okay, those are the components that we are dealing with. All right. So this is going to be equal to, that's 150 sine sine 60 plus 300 sine 60. Okay, so this is going to be equal to 389.71. These are all pounds. This is all pounds. Okay, 150 sine 60 plus 300 sine 60. So 389.71, right. Therefore, the resultant force using Pythagoras theorem is just going to be equal to 389.71 squared plus minus 425 squared, and this gives us, so 389.71 squared plus 425 squared, square root of that gives us a 576.63 pounds. Theta is going to be equal to tan inverse of component in the y, which is a minus 425 divided by the component in the x, which is 389.71. This is going to be equal to minus 425 divided by 389.71. Cos inverse of that, tan inverse of that, 425 divided by 389.71. Tan inverse of that, we have a minus 47.48 degrees. Okay, and then let's find the summation of moments about point A, and clockwise being our reference. Okay, so for this particular, we are going to have a negative moment 150 by 2, okay, minus 300 by 3, okay, and then we have this distance here. We need to account for this distance, which is from there. Let me just place it from here. Due to that force there, we are going to, we need this distance here. We need this distance here like this. Okay, so let's calculate it. So this one is just going to be equal to a 6. This is 6 cos 60. Okay, right. So here, so we indicated 6 cos 60. So here is going to be equal to minus 200 by 2 plus 6 cos 60. Alright. This therefore gives us a value of, can I move this? Maybe I move it somewhere here, and then maybe I move this here like so. Great. So what do we have here? So we have the moment, we have moment A equal to, that's minus 115 by 2 minus 300 by 3 minus 200 times 2 plus 6 cos 60. So this is minus 2200 pounds feet. So let's draw this. So if we are to draw this, So this is how it looks. We have the vertical component downwards like this, and then we have the horizontal, which is 389.71. Then we have the resultant 576.63, and the angle there, which is 47.48. This negative just means we are starting from the horizontal axis, we are going clockwise. As a result, we have a negative. All right, so that is what I want to indicate at A. So let's do that quickly. So I'll draw it just somewhere here, something like this. All right, something like this. I'll draw it there. So this point is A, this point is B. We have our component like so. This is our component there like so. There we go. So there we go. So this one here we said is a 47. This is a 47.48 degrees. And this one here, it is a 576.63 pounds. And then we have a moment which is clockwise. We have a moment which is clockwise, and this is equal to 2,200 pounds feet. All right, let's go to case number 2. So we have case 4-153. All right. So now let's find the moment about point B. So we have summation of moments about point B, and clockwise being our reference. This is going to be equal to, so we have a positive moment 200 by 2, and then here we're going to use the components for each of the forces. Let's start with 150. So this is going to be equal to 150 cos 60 by 4 plus 4 cos 60, and then we have 150 sine 60, and this one is by 4 sine 60 plus we have 300 cos 60. We have 4 plus 3 cos 60. Then we have 300 sine 60, 300 sine 60, and we have 3 sine 60. This one gives us MB is just going to be equal to MB is equal to, so we have 200 by 2 plus 150 cos 60 times 4 plus 4 cos 60 plus 150 sine 60 times 4 sine 60 plus 300 cos 60 times 4 plus 3 cos 60 plus 300 sine 60 times 3 sine 60. Alright, so we have a 2,800 pounds feet. Okay, So let's draw this. We have this, something like this, something like this. Maybe move it a little bit down. Maybe somewhere there like so. Great. So let's call this point A and then this point B. So the forces will remain the same, they will not change. The resultant force will not change. It will be the same. The resultant will be the same. It won't change. The resultant is going to be equal to 576.63 pounds, and the angle also won't change. It will be the same, negative 47.48 degrees. All right. So the angle, like we had said, if you saw, we said the resultant, the resultant in the y direction is negative 425, and we had the positive horizontal component. Therefore, you expect the resultant to be like that, right? And the angle there, okay? And the reason why it is negative, like I said initially, is because we are moving clockwise from the horizontal. Usually, angles, we normally classify them using the convention counterclockwise, positive from the horizontal axis. So horizontal, like so, this is positive, then like so is negative, okay? All right, let's draw that. So like we said, the force will be, the resultant will be the same, something like that. And then let's just indicate the direction of our, so this we said is a 47.48 degrees, and this is a 576.63 pounds. And then we have a moment which is counterclockwise. It's counterclockwise, it's anticlockwise. So it's going like this, right? It's counterclockwise, positive, and the value of this particular moment is a 2,800 pounds feet. Great. So let me just outline solutions. So we had the resultant. We had the resultant there. There we go. We had the resultant. I didn't separate it, so I'll just enclose it like so. And we had the angle also here. We had the angle, and then we had the moment. Okay, the moment for case number 1. And for case number 2, the resultant remained the same and the angle. The only difference here was the moment. All right, I think this is about it. And I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye. See you in my next screencast.